All right, everybody, let's go ahead and get today's program started. Good afternoon, folks. Welcome to the Lunchtime Discovery Series. It is, as always, good to be with you for another edition of our exciting and interesting program. My name is Chris Smith. I'll be your host today for the Lunchtime Discovery Series, and I work over here at the North Carolina Museum of Natural Sciences in downtown Raleigh. The Lunchtime Discovery Series, though, is brought to you and organized by the folks over at the Office of Environmental Education within the Department of Environmental Quality, finding interesting people to bring us interesting stories and give us unique insights into the world of science, nature, education, and more all around us. And a lot of what we talk about is happening right here in the state of North Carolina. So if you've been tuning in a lot, then you know there's a lot of cool and interesting stuff that's happening right here in the state of North Carolina. And we've got a lot of really cool and neat people with awesome and incredible expertise who show up every Wednesday at noon to share with us. We get to learn from them. We get to ask them questions. We have a great time. So I'm glad that you're all here. I'll remind everybody that the program is interactive. So we're going to do the lecture part for the first little while here because our guest speakers are going to impart their knowledge unto us. But then at the end, we've got plenty of time set aside for you to be able to ask your questions. And it helps me out as your host is as we go through the program, when you have questions about something you're seeing or hearing, go ahead and type them up into the chat and submit them. Even if the answer comes up as part of the presentation, it's always great to go back and see what you were thinking as we move through the program. Also, your thoughts and experiences with today's topic maybe as well. Always good to hear your voice, and we want to incorporate all of your thoughts as viewers into the program as well. So don't miss out on the opportunity to interact with us as part of the program. Yeah, you can log into YouTube in order to submit comments, but also if you're on X, formerly known as Twitter, then you can go there and post comments and questions as well. Just use the hashtag Lunchtime Discovery so that those rise to the top for me so that I can see them and ask today's guest speaker. And I'm going to guess that y'all are going to have some questions because today we are going to be getting a look under the hood, as it were, at the Division of Air Quality over within DEQ. Today's guest is meteorologist Bradley McLamb, who joins me now. Hi, Bradley.
Hey, good afternoon, Chris. It's good to be here.
Thanks for joining us. I'm interested in your presentation, not the least of which because I think over the last few months, particularly in the summer, we all got like a crash course in monitoring air quality, which I'm guessing is something you do every day.
Yeah, absolutely. Yeah, this was an especially interesting summer for sure. And I'm excited to talk about it and maybe an aspect or two that folks didn't think so much about while we were getting all that smoke.
Yeah, that'll be really interesting to hear about. I'm excited for it. Let's jump into it. I'll turn it over to you.
All right. Well, thanks. Thanks everyone for joining. Really excited to be here today. Just to kind of pull the curtain back a little bit on what we do as air quality forecasters in North Carolina. So we're going to kind of go through, the basics and then get, kind of into the process that we go through, talk about some interesting events this year, and then sort of end it with some of the tools that we have available that everyone can go and look at. And then, really the final piece is how we put everything together and produce our forecast maps. So excited for this opportunity today. So if we're ready, I'm going to go ahead and share my screen and we'll start. All right, I'm getting the thumbs up. So here we go. All right, so we'll jump into presentation mode. And Chris, are we looking good here?
Looks good to me.
All right, so so an inside look at North Carolina's air quality forecast program, and we're going to jump right into it. We're going to start with an overview of air quality forecasting. So a lot of times when we give these presentations and folks see just what goes into it, they're really surprised. If you think about your weather forecast as a puzzle, your broadcast meteorologist or National Weather Service meteorologist, they're putting all these pieces of data together. The way I explain the air quality forecast is it's like that. Let's say your weather forecast is a 500-piece jigsaw puzzle. The air quality forecast is like a 1,000-piece jigsaw puzzle. We're not only that go into it as well.
Sorry, Bradley. We lost your audio for the last 5 seconds.
Oh no. Okay. Am I back now? Is
I
everything
got you now, yeah, but I had
okay?
lost you for a moment.
All right, yeah. Apologies for that. Hopefully we're good. I've been having a little bit of spotty connection with that, but hopefully we're good now. So as I was saying, the air quality forecast is kind of like an extension of the weather forecasting puzzle. So in addition to considering all the atmospheric components that a weather forecast considers, we also have to consider the human activity elements that may affect the air mass that it's coming into North Carolina and is also coming from other places such as Canada and other locations. First we consider the meteorological forecast, and then after that we're looking at pollution sources and human activity elements. Is there going to be a traffic jam today? Is this a busy travel day? Is it for maybe Labor Day or 4th of July? Are there smoke that's being generated from somewhere, whether it be a wildfire in Canada, something that's local to us, maybe our mountains or maybe along the coast, and we'll talk about one of those events that happened this year, or even pollution transport from even farther away. We actually can get dust from the Saharan desert in Africa that comes across the Atlantic and can impact our air quality. So we're almost having to look at it on a global scale, to see what the air mass is going to be like that's coming into North Carolina on each day. So how in the world do we solve such a big puzzle? Well, with the weather forecast, we know that meteorologists use weather models. Sometimes they're good and sometimes they're not so good. And that's only magnified with air quality, because first we have to try to get the weather component correct. But then we have some, air quality model guidance that we rely on, or we at least refer to it as well. We run our own models at NCDAQ. That's a lineage that goes back through several generations of meteorologists, Nick Whitcraft, George Bridgers, Elliot Tardif, a lot of forecasters that have been part of our modeling history here at DAQ that we're really proud of. We have some of the best, I feel like, in-house model guidance across the entire country. And we have folks and partners from other states that look at our guidance. But even still, it's not always so good, because not only is it trying to, determine the weather aspect, it also is trying to figure out that human activity element that can really make or break the air quality forecast on a given day. And there's no way to really predict if there's going to be a jam up in traffic in Charlotte or Raleigh, or if a wildfire is going to, start that afternoon and impact air quality. So, all that uncertainty is built into every forecast that we make. And, we do our best with the information that we have. And one of the things that we do and that we look at are certain types of patterns. Pattern analysis is a really big part of our forecasting. We know that there's certain types of meteorological patterns that are more favorable for bad air quality, for pollution to build. Some of those are light winds. So if the air, isn't really moving that much, then that allows pollution to kind of become trapped or build up in the same area. Recirculation, that's basically if the air mass, say it moves from Charlotte up to the Triad, but then it circles back around and comes back to Charlotte. Well, it's making a round trip flight, right? And it could be collecting pollutants all the way as it's doing that. And so if it's going to recirculate over the same area, that can enhance pollution on a given day, for the entire day as a duration. One of the meteorological features that is conducive to both of the first two things I mentioned is high pressure. So clockwise rotation over our head. So when we have that, you can get light winds and you can get that recirculation. You also can get sinking air. So if the air is kind of sinking down instead of rising, on a day when we don't have high pressure directly over us, you have vertical circulation of air, and that helps to kind of disperse the pollutants not only horizontally but also vertically. If we have strong high pressure over us, then that also reduces that. So we're really just looking at all the ways that air can get trapped over our region, and that allows pollution to build up. Another way is surface temperatures. We're looking not only at the ground temperature, though, we're also looking at the temperature just above the ground. When the air is getting cooler as the altitude increases, that allows for that vertical mixing that I talked about. But if the opposite is the case, if it's actually warmer just above a cooler layer, then the air gets trapped. So you basically have a lid. And so the air is getting trapped. And if that air is full of pollutants, then that can be a problem for us. And I think folks are probably the most familiar with the last one. Abundant sunshine and warm temperatures, we see that a lot in the summertime. And I think most folks are more familiar with that concept of, we see the ozone or the smog or haze, as people call it, Those conditions are most prevalent, obviously, during the summertime, and they are one, very favorable factor for developing ozone, which is one of the pollutants that we forecast for. So those are some of the basic things that we look for. But how do we actually communicate what the air quality is going to be like? And to do that, we use a system called the Air Quality Index. It's a number-based, color-coded system. So what that means is if you look at the chart on the right, it's coded based on color primarily. So if we forecast a code green, folks know the green is good air quality. And then yellow is a little bit less good. It's what we call moderate air quality. It's really only an issue for unusually sensitive folks to maybe a certain pollutant. If they have some sort of health-based, issue, or they're susceptible to maybe ozone or fine particulates. And then the scale gradually increases from there. So code orange is where more folks start to get brought in: children, the elderly, folks with respiratory ailments. We typically will see, a handful of those days every year across the state in code orange. Then when we get to code red and above, that's where everyone is brought in. And so we encourage at that point everyone to reduce their outdoor exposure, when we're forecasting a code red. And we did have to forecast a couple of those with the Canadian wildfire smoke events earlier this year. Those are really rare in North Carolina. They used to be a little bit more common, but they've become very rare across the state in recent years, thanks to our improving air quality, which we'll also talk about in more detail later. But this is the system that we use to communicate, what we predict the air quality is going to be like, each day. And so we issue a forecast 7 days per week, and we issue it for two primary pollutants. So ground level at the surface, ozone, and fine particulates, or what we call particle pollution. This is tiny droplets that are about the diameter of a string of hair. So very, very tiny. You can't see them, but they can get trapped in your lungs and cause respiratory issues, especially for folks that have respiratory ailments. And like we talked about, as the concentrations increase into that code orange and higher range, for more of us, it can cause issues, with respiratory related illnesses. So those are the two pollutants that we forecast. And then this is the really important thing. And I think this is where it's harder to explain this, but when we're forecasting, so for ozone, we have an 8-hour standard that the Environmental Protection Agency, the EPA, sets. And so we're forecasting an 8-hour average at these levels. It's not just, an instantaneous value or 1 hour value. It's got to be an 8-hour average at these levels, whether it's code yellow or code orange or, what have you. That's what health-based studies have determined is the temporal or time average that can lead to these health issues. And so then for particle pollution, or PM 2.5, as we often refer to it, that's a 24-hour average. So that's the entire day. So midnight to midnight. So we're having to forecast, what we think the hour, every hour of the day is going to be like for PM 2.5. And that's what our forecast is. And as we'll get into later, that can lead to some challenges with not only communicating, but also forecasting. It makes it really hard. We can't be wrong for a few hours and still verify and get our forecast correct. So a little bit more about our history of forecasting air quality across North Carolina. This map on the right shows the forecast regions that we used to forecast for. We would forecast for regions. So if we wanted to forecast for the Triangle area, we actually forecasted for an entire region that consisted of multiple counties. The same for Charlotte. And you can see we had regions across the state. But what you also notice is there's a lot of areas that are white. That means we didn't forecast for them at all. That was typically because those areas didn't experience a lot of air quality issues historically. And so, we focused on the areas that had the worst air quality. But as, time, passed and we had some air quality episodes across the state, and also as we started to engage with folks, people would say, hey, I guess, why does Wilmington not get a forecast? Are we not as important as Raleigh? And we're like, well, of course you're as important as Raleigh. And we had some events in our mountains where even like the southwestern corner of the state, as you can see, didn't have a daily air quality forecast. And so we just come to realize that it's really important to give people a number every day. And as our air quality improved, it started to be less and less representative to forecast, a value for downtown Charlotte, because it wasn't representative of counties surrounding Charlotte. Sometimes it's not even representative of the entire county. Maybe we're only forecasting for a 10-mile area, and we're, incorporating 7 counties. That wasn't, very representative. And so for those reasons, we transitioned to county level forecasting in 2019. So now every county gets a forecast, and each county gets a specific forecast. So no longer is a county, bound to another county's forecast. If we think it's going to be, orange in Charlotte, but green in the counties around it, Union County and Cabarrus County, Lincoln County, all those counties that surround Charlotte, then we're going to forecast, green for those counties. So it's really allowed us to refine our forecasts and communicate better what, our expectations are for each individual county and for every person, which is what, our ultimate goal is. We also forecast for our mountaintop sites. So that gets a separate forecast. You can see the little mountain icons above and below the state here in the image on the right. We also forecast for those as well. Sometimes we can actually see ozone that isn't at the ground, but it's aloft or particle pollution. And sometimes it's the opposite. The air's cleaner up there and it's, a little bit dirtier at the surface. So that allows us to refine that forecast as well. So now all of our counties, or excuse me, all the counties across our forecast area, which is 91 counties of the state, get a county level forecast. We have partners in Forsyth County at the Office of Environmental Assistance and Protection, EAP. They forecast for the 9 counties in the triad. They do still do region-based forecasting, but since it's such a smaller area, their forecasts are still representative for them. But for the 91 counties, the NCDAQ issues forecast for, it's county level and it's every day. So how do we communicate that forecast and kind of what's the daily framework look like? So what you're seeing on the left, this is our brand new air quality portal site. This is the homepage. So this is where we tell folks to go to get their air quality forecast. When they visit the site, they're greeted with their county's forecast. It'll detect what county you're located in and show you, your current day forecast and then the next couple of days as well. With a map, and it also shows you your forecast, your weather forecast from the National Weather Service. Because meteorology and air quality are so inherently tied together that we want folks to realize that, and this, what better way to show it than the professionals that do the weather forecast, and the air quality professionals as well. So we're really excited about that. This was in a partnership with the State Climate Office of North Carolina that we co-developed this tool. And I'm just really excited, to be able to share this enhanced level of, air quality and meteorology forecast at the same time. So when folks do come to that site, they also can read in more detail what we're thinking by clicking on our forecast discussion link. Don't read all the text on the right, but this just shows kind of the general way that it's put together. We have a general discussion, and then we'll break down in as much detail as we need to on a given day, what our expectations are for the air quality based on the meteorology and based on all the things we're looking at. We don't typically go into that kind of detail that you see on the right for a code green day. This was actually for one of the Canadian wildfire days on the right. So that's why there's so much writing on this particular discussion. For a code green day, we certainly wouldn't need to go into this level of detail for each day. So that's kind of an overview of what we look at, and then kind of how it's all, sort of the background and underpinnings of it. So we kind of want to walk through the process now of what all do we look at. So you're probably looking at these maps and it looks like, some sort of abstract painting, right? It's just a bunch of color blobs on a map. Really, the take-home message from this is that North Carolina Division of Air Quality Meteorologists, we do a lot of research on atmospheric patterns that are conducive to bad air quality. And so we've studied and looked at, the meteorological patterns that typically occur on the worst air quality days. And that's changing. The values on the left are different. Those were from 2002 to 2012. That's what the meteorological pattern on average would look like during our worst ozone days. And then on the right, that's what our air quality pattern has looked like in more recent years, 2015 to 2021. The only other thing that I really want folks to get from this particular slide is that this atmospheric pattern on the right is a lot more specific. If you notice, the colors are deeper and it takes a more, specific type of pattern to get bad air quality now than it used to did. Historically, anytime in the summer, if we could get high pressure over us, it led to air mass stagnation and we would have, some ozone issues. Whereas now we're having to have this is called an omega blocking pattern. It's just based on the Greek symbol omega. And so basically it takes this type of pattern. These patterns on the right last for several days. And so it takes several days of the air mass, building up pollution and stagnating before we have air quality issues of the same magnitude as we did, back in the early 2000s. So we stay on top of these kind of things because these are signals for us. Maybe we don't have all the information because we just can't always know exactly what's going to happen. But these meteorological patterns tell us that, hey, the air mass is going to be stagnant. We better watch out and, really keep an eye on air quality monitors and the concentrations that could be coming our way because of this. So the first thing we do is look at that, big 5,000-foot view of the meteorology and the patterns. And then we start looking at all the data that's out there. There's all sorts of computer model guidance data that we have at our disposal, and anything that can impact the incoming air mass, we have to account for. So whether it's clouds, precipitation, the wind direction and strength, all these things that I've already mentioned, temperatures, temperature inversions, and then obviously any sort of smoke or dust, any sort of aerosols that could impact our air quality. We're having to consider all of those things. Then we have our model guidance that we run in-house. This is something that we try to maintain at all times. It's available as part of the air quality portal. When you go to our homepage, you can click on tools, and then we have the link if you want to go directly to it to see this. This is not something that we use verbatim. It's just another tool in the toolbox to kind of help us. It lets us identify maybe trends. There's times when in certain types of patterns that these models do really well in. There's other times when they don't do as well. And so you build up that experience over time and recognize how to use the models. And the same is true for all my meteorology friends listening. The same is true with meteorological model guidance too. There's some patterns that are just a nightmare, even for, weather forecasting models to predict. And the same is true for air quality as well. So the biggest thing to look at from an air quality perspective, as I already mentioned, and this is kind of always an ongoing joke with meteorologists, is, oh, if you just look out the window, I could do better than the meteorologists do. Well, this is looking out not only the window, but this is looking out the big window, right? We're looking at air quality monitoring observations, and we have a great monitoring network in North Carolina that spans the entire state. And so that's the first thing that I look at when I sit down to do the forecast is, all right, what's going on right now? How's the air quality in the backyard, in North Carolina? Are we doing good? Are we not doing so well? And then of course we have to expand that to look at air quality monitors, not only in North Carolina, but also across, the entire Eastern United States, sometimes even in Canada, to make sure that the air quality that's coming our way is clean or not clean. And so, this is just a particular example from several years ago when we had some smoke that was moving our way. And, as time went on, that smoke moved in, and our air quality monitors, of course, picked it up and, started showing increased particle pollution across the state. So this is part of another tool that we have on the air quality portal, the ambient information reporter. Could do a whole hour presentation just on that, which we have done in the past. There's a great user's guide that we have with this tool that I'd encourage anyone interested in looking at this tool to go through and look at as well. But this is a new tool that we also developed that shows not only air quality data, but meteorology data at the same time, and really shows that interaction. This particular graphic that I'm showing now shows our particle pollution readings along with visibility at airport stations and weather stations across the state. And you can see how air quality and meteorology are so closely related. As the particle pollution levels were increasing, the visibilities went down. So of course that impacts, flights and all kinds of other things as well, driving. So yeah, this inherent relationship between air quality and meteorology is something that we've really tried to champion and, increase the awareness of. So that kind of covers everything with the forecasting as far as what we're looking at. So the next thing that we wanted to briefly touch on is air quality trends. How have things evolved over recent years? And I think this chart here tells it the best. So these are statewide ozone exceedance days since the year 2000, using the latest ozone standard that's set by the EPA in 2015. So if you notice in the early and even up to about 2010, on a typical year, we would see anywhere from 40 to 70, around that range, of code orange days per year. And then all of a sudden in about 2012, that just jumped, that just completely fell off a cliff. And there's a number of reasons for that. There's been a lot of North Carolina legislation to curb emissions. We've had the Clean Smokestack Act, which reduced the amount of NOx that was emitted at our big EGU emission sites. On-road emissions have gotten much cleaner. Vehicles are much cleaner today than they were. So as that fleet has continued to turn over and we've got cleaner and cleaner vehicles coming out, we've seen a lot less NOx from that as well. And so all of these things have combined to result in a much fewer ozone exceedance days or code orange and higher days now than we have always seen, in the past. That's great news from an air quality health-based perspective. We're breathing the cleanest air in North Carolina that we've ever breathed. But for me, as an air quality forecaster, that makes things a little challenging because now, it's not like, North Carolina rain day. If the meteorologist says it's going to rain and it doesn't, you're like, it'll rain next week. It's more like a North Carolina snow day. If it doesn't snow today, it may not snow until next year. And so that's kind of where we're at with code orange days now. We only have a handful of them. And so the expectation is that, we need to get the forecast right because we don't want, that perception that, on those days that the health is most in jeopardy for us not to be getting an accurate forecast. So it's definitely kind of ratcheted up the pressure on the air quality forecaster to get those few days when we have code orange and worse air quality correct. And so this slide, it looks a little busier, but it's particle pollution, and we're looking at the same thing. So we're looking at the annual standard, or excuse me, the annual design value, which is just the 3-year average of annual values and how they've decreased over time. It's the same story. So the dashed red line at the very top where you see 12, that was the standard. We've been below that for many, many years now with particle pollution, and we continue to see, a slow downward progression even from that. If you notice the yellow bar, this is the EPA's proposed new air quality standard. It hasn't been officially promulgated yet, but this is what the EPA is considering for a new standard. And most of our monitors are going to meet that if they do implement it. If you notice circled in red, there's a couple monitors that are starting to edge back into that range where we could have to, take a close look. And I'll give you 3 guesses as to what happened this year that has caused that: Canadian wildfire smoke. But we'll talk more about that in a little while. But overall, the story is still the same. Improving air quality. We've been breathing really clean air that's well meets the EPA standards for many years. And so it's great news from a health-based perspective, but it still makes those challenging days when we do have, elevated particle pollution all the more difficult because we have a lot of attention because it's a unique thing that, that doesn't happen very often. And so we really try our hardest to get the forecast, correct every day, but especially on those days, because we know that folks are concerned about it and because they're not as common as they used to be. So I'm kind of already alluding to it, but what are our biggest challenges in forecasting air quality? And it's communicating a complex forecast, as we've already, talked about. And I've tried to, elucidate all the ways that it is challenging and complex in a complex standard. And so we'll talk a little bit more about what that means. But as I touched on, this is unlike any other type of forecasting that you may experience. This is a forecast discussion that I wrote that's very much in the same context or in the same style that you would read on the National Weather Service's forecast discussion page. You don't have to read this. Really, this is just showing you that, a lot of detail goes into just trying to predict, is it going to rain somewhere on a given day? And then if it is, how much and where precisely. We don't have the same leeway that a weather forecast would have. If we're forecasting air quality in Charlotte on a day where thunderstorms are possible, in your weather forecast, you may see, 70% chance of showers and storms. Well, we have to decide 100%, is it going to rain or is it not going to rain? Because if it rains, clouds, precipitation, that's going to cancel ozone formation in Charlotte. But if it doesn't rain, that means, warm temperatures, probably pretty light winds, if it's the summertime, and that could cause some ozone issues. So we have to kind of decide definitively each day what we think is most likely. Obviously, we can't always predict with 100% accuracy, but that can make for some really difficult and challenging forecasts that aren't, we're not able to apply a probability to it like your weather forecast can. On this particular day, after doing the assessment, I had come to the conclusion in the very last line that we have lowered our ozone forecast to code green statewide because I felt like it was going to rain. So let's look at what happened. So on this particular day, you see on the right, the radar loop. This was on June 16th, 2014. It's been a while. But during the afternoon, we had showers and storms that sure enough developed, and they moved over Charlotte. If you notice on the left, those are the hourly ozone readings. And notice in downtown Charlotte, or just to the east, that our ozone monitor had risen well into the code orange range. 71 and above is code orange. And it had shot up to 84. If those showers hadn't hit Charlotte that day, they probably were going to be code orange for the day. But notice, as soon as the showers came through between 3 p.m. and 4 p.m., they dropped from 84 at 3 p.m. to 59 parts per billion at 4 p.m. So that's dropping from well into the code orange range down into just the low code yellow range. And I'm sure the next hour they were code green. So this is the challenge, and we're forecasting, we weren't forecasting what the highest hourly value was going to be in Charlotte for ozone. We had to forecast the entire 8-hour average. So we had to take into account, okay, they're going to rise, but then they're going to fall back if showers hit them. It's a really difficult thing to do on days like this. And, we certainly give it our best shot every single day, but days like this are really, really difficult to accurately forecast. So there's that element, but there's also there's a time and space element to the challenge in air quality forecasting. So this map may seem a little busy as well, but we can take it in, and I think this will make sense. So if you look at the left, these are the maximum temperatures in the greater Charlotte region on July the 11th, 2018. So if you notice, the minimum high temperature was 92.7, so almost 93 degrees. And the highest temperature in the area was 97 degrees. And you see that at a couple locations. So there was a range of 4 degrees in the maximum temperatures on July 11th. That's pretty typical for North Carolina on a hot summer day in July. So on the same day for air quality, the minimum ozone levels and these are the 8-hour values. Again, this is the concentrations that we're forecasting in the temporal scale. So the minimum 8-hour average was 53. The maximum was 77. That's a 24 ppb difference, which is the parts per billion, or the concentrations that ozone are measured in. And then when we apply this to the AQI scale, that becomes 49 AQI for 53 parts per billion. And at the high end, 77 parts per billion is 122 AQI. So in the Charlotte region, that equated to a 73 AQI point spread in the same area that the temperature forecast was only at a range of 4 degrees. So 4 degrees, 73 AQI points. This is why it's so difficult for us to, accurately forecast these maximum values, because the range is so great. And this just really exemplifies how much our air quality has improved, that we don't have widespread air quality issues anymore. It's typically confined to a very small county, 1 or 2 county area at most now. And sometimes it's even less than that. It's great for air quality and health, public health. It's just really hard to, forecast that. And that's why we went to county level forecasting. So here's the time element to this, with these time, based health standards that we're forecasting on. So this is an example of fireworks from the 4th of July. This is something that I'm sure everyone has experienced at some point, but you go out and celebrate the 4th of July fireworks. And, after it's over, I've even experienced this at Disney World in the wintertime. But, the big fireworks show goes off, and then you're walking back to the parking lot and you're just engulfed in smoke. And you're like, wow, this is terrible. Those temperature inversions at night can trap that smoke near the surface. And when it happens, the air quality can be really bad for a period of time. And so on July 5th of 2021, that's exactly what happened around the state. We're focusing on our Millbrook monitor in Raleigh for this one. So the chart on the left is showing the 24-hour average. So from midnight on July 5th until midnight on July 6th, it was 29.5. That's a high code yellow, but not code orange on the AQI scale for fine particulates. Now on the right, we're looking at the hourly values. If you notice, the first few hours of July 5th, we were in the code red range, which is, unhealthy for everyone. And then gradually, as the day progressed, the air quality slowly improved. And most of the day was, upper code green or low code yellow. So not too bad. But when it all netted out in the average, you got that 29.5. It's really difficult because, if folks were outside for the fireworks celebrations and, coming back to their homes, the air quality was probably pretty bad. But most of the day, the air quality was pretty good. And so trying to communicate that, and, that perception can be that, oh, those air quality forecasters, they should have, issued a much higher air quality forecast, but we're having to look at the entire 24-hour time frame. So makes it very difficult to communicate. We try to really elucidate and explain in our forecast discussions, these type of evolutions when they happen. And it's really one of the only ways we have to try to explain how we think a day is going to evolve like this, because giving it one number is almost a disservice because of how complicated it is on a given day. So the other thing that we're really passionate about at NCDAQ is that our forecasts are not predictions of future monitor readings. We do not forecast for the air quality monitors. Those monitor data that we have is invaluable to us and to our forecast, but we're forecasting for neighborhoods and for people. If we think that the values in a portion of the county that doesn't have a monitor is going to be higher than at the monitor, then that's the value we're going to forecast. So what we forecast is the highest air quality reading for a given pollutant, whether it's ozone or fine particulates, and what it might be for the given county, the entire county, regardless of what the monitors might show. And our monitors are strategically placed that on average throughout the year, they're going to capture those values more times than not. But just depending on the meteorological pattern on a certain specific day, that plume of ozone that maybe is only 10 miles wide can miss the monitor. And so we're going to try to still forecast for that, even if the monitor doesn't show it. So that's something that we always want to stress, is that, rely on our forecasts and read our discussions, and don't just look at the monitor data, because sometimes there's a little bit more nuance to what we're forecasting than, maybe what the monitor is showing at a particular time of day. So this is a little bit technical. I don't want to spend a whole lot of time on this. But basically what this is showing is that on a given day, our model data that we have and our monitors, we're doing a great job of representing this. There's a model that was the NOAA model ran by EPA and the National Weather Service, or NOAA, the NOAA administration. It was showing that at a monitor at 5 p.m. in Union County, southeast of Charlotte, that the hourly value is going to be 90. This is at our Monroe monitor. And sure enough, the value was 90. So it was doing a great job. The model was doing a great job, and it's verified by the monitor. Well, the model at a different latitude and longitude, about halfway between downtown Charlotte, and this monitor was showing a 17 ppb higher ozone value predicted. So the point being that in between the monitors, the ozone could be significantly higher on a given day. And that's what we're trying to forecast for. We're trying to forecast that high value, even if it never makes it to the monitor. So that's really the take home from this slide. And then the other thing is that ozone has become more and more localized because of the improving air quality, because of the reduced emissions. We're not going to always see, every ozone monitor be code orange when we forecast a code orange. Normally, we're only expecting one or maybe two monitors to represent that value, depending on where the winds are blowing on a given day. And so the graph that you see or the chart that you see on the left is representative of that. We often see very large spreads in our monitor readings from one monitor to the next. And over the scale of just 10 or 15 miles, we can see a 20, 30 parts per billion difference. And that's the difference between code green and code orange, or, even maybe code red. And you can have that spread over just, 20 or 30 miles. So makes it very, very difficult to verify, because sometimes these values we don't think are hitting the monitors, but we feel like they're somewhere. And so that's what we're trying to predict. And we don't have a lot of margin for error, when we're verifying a forecast based on, maybe one monitor, capturing that. So verifying our air quality forecast is a bit challenging on a given day. And so that naturally leads to the next point, which is the consequences of being quote unquote wrong. If our forecasts are perceived as not accurate and not correct, then we can lose the trust of the public and our media partners, and have diminished credibility. And we definitely don't want that. And so that's why we've developed these new tools in partnership with the State Climate Office to better be able to discuss our forecast and get the messaging out about, how difficult it is and what we're expecting on a given day. We have a number of other ways through social media. We have a forecast Twitter account. We also have air quality blogs that we write, that we try to go into detail about, these events and what's going on, so that, that we don't lose that credibility with our public, because we value that. And, it's very important to us that folks don't think we're just throwing out numbers and, impacting people's days, without, having a valid reason to do that. And we certainly always do, do our very best to produce the best air quality forecast we can. So with that, I thought I'd spend the next couple minutes just talking about some of the interesting events of this year. I know everyone is thinking Canadian wildfires, but we also had an interesting event earlier this year, which was the Great Lake Fire. So this was in Craven County. It burned over 32,000 acres, and it started in April 19th. This will kind of give an idea of what we look at and kind of how our forecasts evolve and how dynamic the forecast situation can be. This was a day that initially started out pretty quiet. We are constantly observing satellite and monitoring satellite to make sure that we don't see fires popping up. Well, on this particular day, I noticed this around 1 o'clock in the afternoon that there was a fire developing, and this looked pretty serious. There was a lot of smoke coming out of this fire, and it was developing fast, it looked like. So our response was to issue a code orange quickly to cover the Craven County area, because it was very obvious that there was a fire burning at this point. And so at 12, actually this was at 12:11, we issued a code orange, so we were on top of things. But in a couple hours, this thing had really blown up, and now we had smoke expanding across a lot of eastern North Carolina. And so we started getting reports as well that there was ash falling from the sky in New Bern. Visibility at some of the local airports had dropped to 3 miles. So these were huge red flags to us that this was a major air quality episode at this point. And so we responded accordingly and issued code purple and code red. So very unhealthy for people in the vicinity of this fire. And even for further away folks, we were issuing code oranges because this smoke plume was extending, to our border at this point. And so this is kind of the process that we would follow in an event like this. And again, we try really hard not to overwarn, but we're certainly never going to underwarn. And we want to make sure that folks are able to get the proper notifications of air quality hazards. So on Friday evening, we were looking at monitors in Virginia, and even into Virginia, they had hourly values in the code red range. So this was a plume that had started in Craven County, North Carolina, and was carrying smoke and fine particulates in the code red range all the way to Richmond that evening, just to give an idea of the impacts. And then if you notice, monitors, just a little bit further west are code green. And so, and even a little bit further east. So this really kind of highlights again, the temporal and also the spatial scales that we have to deal with and how, small they can be at times. So on Saturday morning, we continued to monitor this situation. We still were seeing hourly values in the code red and above range at some of our monitoring sites that were near the fire. So we continued to go with that forecast that we had generally with a few small adjustments. And we just kept monitoring it. This was a day, though, that we had a cold front approaching in the afternoon, back to the meteorology. And we knew that there would be rain with that front. And so we were really optimistic that by Sunday that hopefully that rain would, kind of put a damper hopefully on the fire and reduce that smoke and elevated fine particulates across the state. And so that's what happened. And so, we reacted on Sunday by lowering the forecast, and thankfully this was sort of the ending of the Great Lake Fire, and that rain really did a number. It came at just the right time and really helped the firefighting efforts, and we were really grateful for that. It was a really busy week in early April for us, though. We had 5 consecutive days of code orange or higher air quality forecast across the state. So we thought that was a busy week, and we thought, wow, we're glad this is behind us. And little did we know this was only just the beginning of our fun this air quality season. So the big one, of course, the Canadian wildfires, was right around the corner, even though we didn't know it at the time. But even as this event was happening with the Great Lake Fire, the stage was being set, if you will, to our north in Canada. There was a large area of high pressure that had persisted across the region for much of the spring, and it was resulting in some unusually hot and unfortunately really dry conditions across Canada. This was the drought monitor at the end of May. And so you can see there was a lot of drought in Canada, even as May ended and we got into early June. Very favorable, obviously, for, rapid wildfire development. And unfortunately, in June, there wasn't a lot of relief. The drought conditions expanded. So that meant that, there hadn't been a lot of rain in June. And so by the end of June, 60% of Canada was abnormally dry or worse. So, these were very poor conditions for those folks, unfortunately, and it impacted a lot of other folks as well. And you can see, looking at the size of the Canadian wildfires, it really exploded in May as that high pressure had sat there and the drought conditions set in. That's when the fires really started to take off. The red line is the is this year's wildfire season acreage burn compared to a typical year, which is the blue line. So you can see just what an anomalous season it was. And of course, as all these fires and acres of land are burning, prodigious amounts of smoke was developing. This is a look through October at the carbon emissions for Canada from the wildfires. And you can see it just blows every other year out of the water since 2003. That's what all the small gray lines are, all the years from 2003 through 2022, with the red line being this year. So just an incredible wildfire season. And typically that wouldn't be so much of an issue for North Carolina. As we all know, we don't get a lot of cold Canadian dry air in June in North Carolina. That's typically saved for January and February. But unfortunately this year, we didn't see a lot of Canadian air in January and February. We got a more winter-like pattern in June of all times. And of course, that just happened to be when all that smoke was hanging around. But we had that big area of high pressure still sitting there in June that led to the drought conditions in Canada. It was accompanied by an area of low pressure off of our coast. And so those clockwise rotation around the high and the counterclockwise around the low, it just directed all of the wind flow from north to south. And it just sent that ginormous plume of smoke into North Carolina. But it also resulted in really cold temperatures. Canadian air, cold Canadian air. And so it was a top 10 to top 15 coldest June on record for many parts of the mid-Atlantic. For North Carolina, it was the 13th coldest June on record. So, that's a part of this that isn't talked about as much. And it's unfortunate because it would have been a really nice June had it not been for all the, the bad air quality. But unfortunately, we had that. And so we can see here that this was on a particular day. This was on June 6th, just a huge plume of smoke just being driven straight down into the eastern United States, including obviously North Carolina. So we had cool temperatures, but unfortunately we had some, pretty poor air quality on a few days. This was on June 29th. Many of our particle pollution fine particulate monitors across the state were in the code orange range. We had one that was code red in the Triad region. And then we had another episode centered around July 18th, where even more of our monitors were code orange. So we had 2 periods of 2 days each, so 4 days in total that really we had a lot of monitors reading in the code orange and above range. So, some really poor air quality on those days. This is a really interesting chart that kind of shows the difference between this year and last year, our fine particulates statewide. So this is the statewide average. You can see there's a 6 microgram difference in June of last year versus this year, with obviously this year being higher. And as we progressed and the smoke has become less and less, we're returning back to more of that baseline, typical average that we would normally see. So just really goes to highlight how much of an impact the Canadian wildfire smoke had on our fine particulate readings in the state this year. And so I think these charts pretty much say it all. So these are the typical exceedances that we would see through early October. From 2016 to 2022 for PM, for fine particulates, we typically only see just a couple of, code orange and above exceedances each year. And this year we saw over 50. So very big dramatic difference. And the same kind of thing is true with ozone. We've seen a steady decrease in the number of ozone exceedances across the state in recent years until this year. We really saw a big increase. And we definitely think that the smoke has played a role in that. And that's kind of an area of ongoing research right now, is to determine how much of an impact does smoke play in ozone formation. So stay tuned to that, but that's something that we're definitely tuned into, and we're really trying to be at the forefront of that research and analysis as well. So real quickly, running a little bit short on time, but I wanted to talk about how all of these new tools and outreach efforts we've made, how it's made an impact on our public engagement and the rise in public engagement we've seen. So in previous years, in some of our big air quality events, we would typically see on average at most around 10,000 viewers on a big day, such as a Saharan dust event or a wildfire episode. But this year, with the Canadian wildfire, we saw over 160,000 page views on our air quality portal during the early period of June when we had the first big impact. So just a tremendous increase in the amount of viewership. And that's what we're really wanting to see. We want folks to come to us for the air quality forecast information and for the air quality data, because, we're the experts on that, and we can communicate and give the most accurate. You're getting it directly from the source. And so that we're really happy about that. And we hope that continues, that folks will see the value and come in directly to us for that information. Even our partners like the National Weather Service are referring to our forecast discussions now and communicating that with the media. So that's great. This was even on a code green day when there was just some smoke nearby that they had referred to our forecast, because there was a little question about, is that smoke going to be an issue or not? So we're really happy to see that. And we've had great partners, whether it's Secretary Beiser, Governor Cooper, that have shared our forecast information, especially on these high impact days. And so that's awesome. That's really helped us get our message out to folks. We have plans to develop English and Spanish alert videos that will start coming out soon in the future to reach even more audience members and, folks. So, we're continuing the efforts to engage and increase that, interaction with our customer base. So I know I'm getting a little bit short on time, but I wanted to really quickly do a live demo of some of the tools that we do have at our disposal. And then I'll try to open it up for questions. So let me share my browser window really quick. Let's see. Chris, are we doing okay on time to do this?
Yeah, I think we're doing great. We've got a few questions in the chat, but we've got time to get to them.
Okay, awesome. So yeah, let me reshare my browser. Okay. Does this look okay to you, Chris?
Yeah, looks good to me.
Okay, awesome. So what this is our air quality portal. So when folks come to airquality.climate.ncsu.edu, this is our homepage that we want folks to come to get the air quality forecast. And so as I alluded to in the presentation, it's catered to where you're located at. So if you're in Wake County, it's going to show you your Wake County air quality forecast. Wherever you're at on a given day, it's going to show you the latest air quality forecast, and then the next couple of days as well. Right now, there seems to be a forecast data outage for the National Weather Service. So those forecasts aren't showing up. I could try to do a quick refresh, see if that's come back. Oh, it hasn't come back, but you saw it in the presentation earlier. Typically, your National Weather Service forecast would also accompany that. And so then down below that, we have some data and tools that we're really proud of as well. We have our ambient information reporter tool. This shows our hourly air quality conditions across the state. You can go back and forward in time. During ozone season, it's going to just default to showing the hourly ozone values along with the meteorological conditions as well. So by default, it shows the hourly air temperature, but you can come in and choose, dew points and winds and wind gust, all kinds of information, precipitation. And it really helps folks to kind of get that intuitive feel for how the air quality is impacting meteorology, or how meteorology is impacting the air quality. We have our forecast conditions information, our forecast on a tab in this as well. There's some other goodies if you go to the hourly information, but we'll save that. And then we have past conditions. So if there was a bad day in the past and you can't remember what exactly was going on, or maybe you just want to check to see what the air quality was like, you can come in here and choose any day going back to January 1st of 2016 to see what the air quality was like on a given day. So we're really proud of this tool. Again, refer to the user guide for a whole lot more details on the ambient information reporter. Another tool that we're really proud of is our ozone design value predictor. This is kind of a technical tool, but the really cool thing about this is you can get a really quick snapshot of how is the air quality attainment going for ozone for North Carolina. If your monitors or the monitors around where you live are green, that means that your monitors are not only attaining the ozone standard, but they're unlikely to exceed it anytime soon. And so you can see we're really doing a great job in North Carolina. We only have one monitor that has just recently turned yellow that it might exceed. And that's only if it continued to have some bad days, which this ozone season's almost over. So they're going to be in good shape for this year. But this helps us also and our management to continue to monitor. And, if there ever is a monitor that shows up as yellow, or, even worse, if they do start to exceed, it gives them the ability to, really, move into that area and, try to think about what are other ways that we can do better at attaining air quality if that was, situation was to ever arise. So this is a tool that we use frequently to, keep track of how our monitors are doing and what our attainment status is like all across the state. We have a windrows climatology tool, which just kind of shows what the wind directions have been like at a given location over time. This is our air quality model guidance tool, which shows our forecast. Won't show that right now since, we pretty much had already looked at that earlier. We have an air quality blog where we talk a lot about, the different events and things that have happened across the state in recent years. So encourage folks to always keep checking back on that. We share that on our forecast Twitter account. And anytime there's a big event, we do try to recap it, like the Canadian wildfires back in June. Then at the bottom, we have our social media account, our forecast Twitter account at NCDAQ forecast. And we put out that forecast every day for folks to, have available for them there. And so the last thing I wanted to show really, really quickly, this is kind of the secret behind the sauce, right? This is where we actually go to build our forecast. We appropriately enough call it the forecast builder. And so it's a really handy tool, and we can issue forecasts for all 91 counties that we're responsible for now faster than we could have issued county forecasts for the 7 regions that we had before. So let's just say on a given day that we think the air quality is going to be generally good most places. So we can issue a statewide 45, but then we could come in and say, all right, I think that we may have a problem area, in a given area. We'll just go with the Raleigh area for now. So we can actually come in here and paint this area however we need to based on the conditions of the day. And we can, adjust it for those areas. We can do it, at that level, or we can even do it at the county level. So let's say we want to adjust that a little bit more. So maybe a couple of the counties surrounding Raleigh are going to be a little bit lower. So we have a lot of options at our disposal for really being able to refine the forecast and make it as accurate as we possibly can. And so this has all been developed in partnership with the State Climate Office of North Carolina. They've been outstanding partners that, we're really happy to have that relationship with. And these are all tools that are for the benefit of all of North Carolina residents to get our air quality forecast. So I want to go ahead and wrap it up there, but just thanks again for this opportunity to share a little bit of, behind the scenes of what we do. And I hope everyone has a great day.
Bradley, thank you very much. Excellent stuff. Are you ready to take some questions?
Let's do it.
All right. First one I got for you comes from Glenn. How long does a computer run take, and how do you evaluate the quality of your prediction against the day's actual values?
Yeah, that's a great question. So our typical in-house runs take about 4 to 6 hours to run for 3 days. And we're using our air quality monitoring data to verify how the forecasts are doing. And we're constantly making adjustments and doing research on our forecast models to improve their performance. But we utilize the observational data to do that. You can't beat real world physical data. So that's always the underpinning of all of this.
Cool stuff. Next one that I had for you. What places in North Carolina, the U.S., or the world do you think or know have the best air quality?
Oh, goodness. I really honestly think that North Carolina has some great air quality. We've been meeting all of EPA's air quality standards for almost 3,000 consecutive days now. We have outstanding air quality here. I would argue that it's some of the best in the nation for sure. So that's my answer.
And then, okay, this one's an interesting one. Do you see any correlation between noise pollution and air pollution? I don't think your monitors pull in local decibel levels.
Right. It would really depend on what's generating the noise pollution. If it's big trucks that are emitting, other types of air pollution, then that could be a correlation. But that's not something we've ever, I don't think, studied too much. At least I haven't. But it would really just depend on what's causing the noise pollution. Are they emitting, emitting stuff into the atmosphere? That would be the question to answer there.
Well, it reminds me of the example you gave of the fireworks shows.
Exactly.
Right. That's going to definitely be, that's loud. And it's something that can impact the air pollution.
Right. But if it's a rock concert, then probably not.
Right. Exactly. Or, I guess like cities tend to be louder than rural areas generally, but
right.
People setting off a bunch of fireworks in their backyard could cause really localized. Okay. That's an interesting one.
Yeah, it is. That's a good one.
And then, okay, this is a good one from the same person, from Kayla. What did you study to get into this kind of work?
Oh, great question. So I have a bachelor's of science and a master's of science in meteorology from NC State. So have a really strong background in meteorology. That's what really it takes to be an air quality forecaster. I worked for a year at the National Weather Service before coming to NCDAQ. So having that really strong foundation in meteorology is absolutely essential to being able to add that second piece of the puzzle, the air quality forecasting, and be able to take on all of that.
There you go. Uh, well, it looks like that's going to be our time. So, Bradley, thanks for being with us on the Lunchtime Discovery Series. This was cool stuff. It was really interesting to see the depth of information that you use and the amount of information that you are sharing with the public pretty much every moment of every day. Really appreciate it.
Yeah, absolutely. Well, I appreciate the opportunity. And yeah, these are great questions from everyone too. So thank you very much.
Excellent stuff. Everybody, thanks for tuning in to today's program. We will, of course, be back here again next Wednesday at noon for another edition of the program. Make sure that you head to eenorthcarolina.org or the museum's website, naturalsciences.org, where you can see upcoming programs and events just like this one that you can log into, attend in person. We've got all kinds of fun stuff happening. And this series, we've got a great lineup of guest speakers for the month of November, so you don't want to miss it. We're going to keep the learning going every Wednesday right here at noon on the museum's YouTube channel. From all of us here, thank you to the folks in DEQ, including DAQ and the Office of Environmental Education, the museum's digital media team, for all of the help today. Everybody, we'll see you again soon. Take care. Go breathe clean air.